Okay, continuing with our discussion, areas under the normal curve. So problem number 5. Given a normal distribution with mean of 40 and standard deviation of 6. So find the value of x that has, you call this, this one, 45% of the area to the left. Okay, so the probability of our z-score is given as 45%, where the probability of 0.45, let's look under the normal distribution table. So that gives us 0.45, and that is positive 0.45. Okay, so 0.66736 0.45. That is the probability of z, so it should be under this table. So you'll need to look for 0.45. Okay, so 0.45, 0.448, so 449, 4546. So I rounded to the 2 decimal place, so it should be 45. So it should be 0. To call this 13. So it should be this one. Okay, rounded to the 2 decimal places. It's above 45, so it should be taken as this one. Okay, so 0.13 negative. Okay, and then using the formula of the z-score, okay, solving for x. Okay, recall that z-score is equivalent to x minus mean all over the standard deviation. Then simplifying that equation, you will be arriving to this formula. So where x is equivalent to z multiplied by the standard deviation plus its mean. So that is z is negative 0.13 plus multiplied by 6, and that is plus mean, which is 40. It's given here. So you'll have an answer of 39.22, and that is the value of x. Okay, now moving forward, same problem, solving for x that has 14% of the area to the right, so probability of z. Okay, so it means to the right, so you'll need to have an answer of 1 minus 14%. So you'll arrive to an answer of 0.86, and you'll need the table to analyze 0.86. 86, so probably this one, 0.86, 1.08. Okay, and then using the formula again, solving for x. So this is the z, 1.08 multiplied by the standard deviation plus the mean. Okay, you'll have an answer of 46.48. Okay, and now the application for the normal distribution. So certain type of storage battery lasts on an average of 3 years with a standard deviation of 0.5 year. Assuming that the battery lives are normally distributed, find the probability that a given battery will last less than 2.3 years. Okay, solving for the z. So x is given. Okay, and then this will be the mean, 3 years, and the standard deviation is 0.05. So notice here on the average, that means 3 years is your mean, and this will be your x. Okay, so that is 2.3 minus 3 over the standard deviation of 0.5 years or year. We'll have an answer of negative 1.4. Okay, for the z. So that gives us negative 1.4, negative 1.4. Okay, so you'll have an answer of 0.080 76. Okay, and then for the application of number 2, an electrical firm manufactures light bulbs that have a life before burnout that is normally distributed with mean equal to 800 hours. So this is the mean 800 hours and the standard deviation of 40 hours. Find the probability that a bulb burns between 778 and 834. You have your x1 here and x2 here. So you have 2z, so z1, x minus mean all over the standard deviation, that gives us 778 for x1, and then 800 for the mean, standard deviation 40. Have a 0.55 negative. 0.55, 0.5. Okay, so that is under this one. So 0.5, 0, 1, 2, 3, 4, 5, 2, 9, 116, 29116. Okay, and then for Z2, X2 is 834 minus 800 plus then all over standard deviation 40. You'll have an answer of 0.85, positive 0.85, 05, so 80234. So error 0.8023. Okay, 4. Okay, then the probability will be the difference between the two, higher, minor, lower. Okay, so you'll have a 0.5 il 5111. And then for the application number 3, in this industrial process, the diameter of a ball bearing is an important component part. The buyer sets specifications on the diameter to be 3.0 plus or minus. Okay, this will be the precision, 0.01 centimeter. The implication is that no part falling outside these specifications will be accepted. It is known that in the process, the diameter of the ball bearing has a normal distribution with mean of 3 and standard deviation of 0.05. On the average, how many manufactured ball bearings will be scrapped? So you'll have your limits here. Okay, so your x1 is 3 plus 0.01 and x2 or x2 will be x1 is 3.01, 0 minus 0.01, and x2 will be the higher, which is 3.0 plus 0.01. So that gives us 2.99 and 3.01 centimeters. Okay, and your mean is 3 and the standard deviation is 0.05. So you have your z1, x1 is 2.99, which is 3 minus 0.01 minus 3 all over the standard deviation. That gives us negative 2. And for z2, 3.01 minus 3 all over 0.05, 0.005, that gives us a positive 2. So you'll have z1 negative 2, z2 positive 2. From the table, negative 2, okay, 0.02275, okay, and then for z2, which is positive 2, 97725, okay, then probability will be the higher minus lower, so that gives us 0.9545. So the question is that how many manufactured ball bearings will be scrapped? So that will be the probability of failure or the complement of this one. Okay, this is the probability probably of success, and this will be the probability of failure that the bearings will be scrapped. So you'll need 1 minus 0 point. Okay, this has a 0.9545 to this value. Okay, so you'll have an answer of 0.0456. These are the probability that the ball bearings will be scrapped. Okay, now regarding normal approximation to the binomial distribution, recall that probability of success is P and the probability of failure is letter Q. Okay, so in the binomial random variable, the mean is equivalent to n multiplied by P, where n is the number of uh, sample, and then the P is probability of success. And the variance is given as NPQ. And then limiting this distribution, we'll have the z-score will be computed as x minus mean, where mean is NP. Okay, and then this is the standard deviation, which you'll notice here. This is the variance, and the square root of that variance that gives us the standard deviation. And then application, the probability that a patient recovers from a rare blood disease is 0.4. So this is the probability of success, P. If 100 people are known to have contracted this disease, what is the probability that fewer than 30 survive? Okay, so the probability of success is 0.4, and the probability of failure, which is Q, is 1 minus 0.4, so that gives us 0.64 Q. Okay, so X will be, okay, you'll notice here, what is the probability that fewer than 30 survive? So X is less than 30. Okay, so you'll have the lower boundary, okay, for X, 29.5 minus NP, N is 100, and the probability of success is 0.4. Then the standard deviation is square root of N, which is 100, multiplied by P, 0.4, and Q is 1 minus N, or 1 minus P, which is 0.06. And you'll have a z-score of negative 2.14. And from your table, negative 2.1, okay, 0, 1, 2, 3, 4. Okay, so you'll have 0.1618. Okay, so that gives us the probability that fewer than 30 will survive is 0.0162. Okay. For example number 2, multiple choice quiz has 200 questions, each with 4 possible answers, which only one is correct. What is the probability that sheer guesswork yields from 25 to 30 correct answers for the 80 of the 200 problems about which the student has no knowledge? So there will be x1 is less than and x2 will be greater than. Okay, so the lower boundary of 25.4 25 is 24.5, and the upper boundary of 30 is 30.5. So you'll have your x1 as 24.5 and x2 30.5, and the number n will be 80 out of the 200 problems. So your n is 80, and the probability of success is 1/4, 1 out of 4, and the probability of failure is 3/4. 3 out of those 4 possible answers are incorrect. Okay, so your x for z1 will be 24.5 minus 80, and this will be the p, probability of success is 1/4. Then square root of n is 80, 0.25 is p, and then q, or probability of failure, will be 0.75. That is 3/4. So you'll have an answer of 1.16. Same goes with z2. X will be 30.5 minus n is 80, and then p is 0.25. then 80 all over 0.25, 0.75 squared. So I'll have an answer of 2.71. Then from its table, 1.16, 2.71, so 1.16. Okay, 0, 1, 2, 3, 4, 5, 6, 8, 7, 6, 9, 8. Okay, and then 2.71, 2.71, 99664. Okay, then z2 minus z1, that gives us 0.1196. Okay, so that finishes our discussion.